Okay, so hello everyone and welcome to today's class. So today we are going to discuss some of the things we are going to cover in the advanced ML classes. So we've already covered the basics of machine learning. We've looked at how we work with classification and regression models. So that is all on supervised learning models. So what we haven't covered so far is the unsupervised learning models, and that is on the part of clustering and dimensionality reduction. But in the next coming few days, we will have a look at that. Okay, so let's go here and see what we are going to discuss as of today. So we discussed other models. So for example, we discussed linear regression, and we said that the equation for linear regression is equals to y is equals to mx plus c. So that's the equation for linear regression. So what we are going to look at today is something called decision trees. And decision trees can be used for both classification. So it can be used for both classification and regression. So that's the first thing you need to note. And how do we create regression tree models? So what I'll do is I'll give you an example. So let's say you have a job, okay? And apart from having a job, we'll check your family, then we'll check your salary, okay? So something like that. And what we are trying to predict is, let's say something like, will you be able to stay on your own or not? So will you be able to rent a house or not, based on these features that we have there? So what we will have here at the top is something like this. So for us to create a decision tree model, so we will have the top part here, which we are checking for the job. So this is a tree. So remember, a tree has branches and the roots. So here we can have Y for yes, then N for no. So I'll have N for no, then Y for yes. So we are creating our tree. So if you don't have a job, then what you will be required to do is stay at home. So H will represent home. Okay. So this is our output if you don't have a job. Then the next thing we are going to check is family. So do you have a family? So we can say something like no or yes. So if you don't have a family, you can still stay at home. So chances are you can stay at home. Then if yes, we can check your salary. Okay. So if salary is maybe greater than 10,000, so something like that. So we can have something like no, yes, then here we can say rent, and here we can say stay at home. So something like that. So basically, this is how a decision tree is made. Okay. So what we have here at the top, so this is the root node. So we have nodes and we have the decisions that are to be made. Okay, so let's open the notes, the theory part notes, and see some of the things that we need to discuss here. So we will check the decision trees part here. Okay, so here you can see key concepts in a decision tree. So we have the nodes and the splits. So we've already looked at that. So here we have the nodes and here we have the splits. Okay, so the splits are the different decisions that you are going to make. So Yeah, this is how a decision tree model looks like. And when we go to the practical part of this session and fit one, you'll get to visualize one and see. So when we are working with this decision tree, so if I take maybe this part where we have the job, then we have the Y and N. So in between here, we have probabilities, okay? So we have probabilities that maybe you can be classified as having a job or not. And this feature here carries some weight, and the topmost feature here can be any feature that we have over here. But when fitting a decision tree model, so what we usually take is the first feature. And basically that's how a decision tree based model works. And that's a disadvantage when it comes to working with decision trees, because this first item that is up here is the first feature in your data set. So how do you solve that issue? So what you usually do is you come up with another model which is called the random forest. Okay. And the random forest is a combination of different decision trees. So it's a combination of multiple random decision trees. So for example, we can have these. So J to represent job. Yes, no. So that's one. Then we can have these starting with family. So yes, no. Then it goes on, goes on, goes on, goes on. Then we can have these salary being at the top. Yes, no, something like family, for example. So something like that. Then what you usually do is you combine these three and come up with an average score. Okay. So you combine the score of all these three decision trees and come up with an average score. So that's what we usually do when it comes to random forest. So yeah, that's what we have. So we have some key concepts that we need to discuss when it comes to decision trees. So let's look at the theory part that is here. So decision trees are a popular machine learning algorithm used for both classification and regression. So the key point here is decision trees can be used for both classification and regression. So you can fit both regression and classification models using decision trees. Okay. So they work by recursively splitting the data into subsets based on the values of the inputs. So I've shown you this. So what we usually do is we usually split. We usually split, do some splits based on the features that we have in the data set. Okay. So they work by recursively splitting the data into subsets based on the values of the input features and then making a decision or a prediction. So it's more of a decision at the leaf nodes based on the majority class or average target value of the samples in the leaf, in each leaf. So here we have some key concepts. So we have nodes and split, entropy and information gain, Gini impurity, pruning and advantages and disadvantages of decision trees. So what we'll do is we'll go and discuss those key concepts. So we have nodes and splits. So a decision tree is a hierarchical structure consisting of nodes of connected by branches. So I showed you these. So these are the nodes. So for example, this part where we have job, that's one node. Here where we have family, that's one node. Here where we have salary, rent, H. So all H's here, these are decision nodes, okay? And all the other nodes where another decision must be made are what we call the root nodes, okay? So let's proceed. So the tree recursively splits the data into subsets, with each split corresponding to a specific value or a range of values of the input features. So leaf nodes represent the final prediction or decision. So if we go back to our drawing, so where are the leaf nodes? So I can highlight these with a different color. So these are the leaf nodes. So which represent the final decision. Okay, so the final decision that we've made. Okay, so leaf nodes represent the final decision, which is based on the majority class or average target value of the samples in the leaf. Then, so the other nodes that we have are what we call the root nodes. Okay, so let's proceed. So we have another thing called entropy and information gain. So entropy is a measure of the randomness or impurity in a set of data points. So in decision trees, entropy is used to quantify the disorder in the target variable within a subset of data. So information gain is the reduction in entropy achieved by splitting the data based on a specific input feature. Decision trees use information gain to select the best feature and value for each split. So aiming to maximize the information gain at each step. So with practice, you'll get to understand these better. Okay. Then we have another thing called Gini impurity. So this is another measure of impurity in a set of data points. So it calculates the probability of misclassifying a randomly chosen sample if it were labeled according to the class distribution in the subset. So like entropy, Gini impurity is used to select the best feature and value for each split. So these are the things that we use to decide what should be used maybe at this level, what should be used at this level, and what should be used at these levels. So those are the things that we use to decide which features are more important. So go to the top, and which features are less important. So go to the bottom. Then we have pruning. So pruning is a technique used to reduce the complexity of a decision tree. So just like, so if you've done agriculture before, you know what pruning is. So thereby preventing overfitting. So overfitting occurs when a model learns the training data too well, capturing noise and anomalies. So when we will be discussing deep learning models, we will discuss overfitting in detail, and then you will get to see how you can overfit on your data. Okay. So overfitting occurs when a model learns the training data too well, capturing noise and anomalies that do not generalize well to new unseen data. So pruning can be performed by setting a maximum depth of the tree or by removing branches that do not provide a significant improvement in the impurity measure. So if this decision tree, let's say, is kind of big, and we need to like make some reductions, so we can do pruning and eliminate some parts that we don't need. So let's say, for example, if family is not significant, then we can delete this part, and then we can have job, salary. So we can confirm, does someone have a job? Yes, if he has a job, so what is the salary that he is being paid? And we can ignore the family part because maybe these might be noise. And that's all about pruning. Then what are the advantages and disadvantages of decision tree? So advantages are it is easy to understand and interpret. So it's just a tree which can be visualized. So it has branches and it has the decision notes. So can handle both categorical and numerical features. So when fitting a decision tree model, you don't have to do any encoding because it can handle both data types. So you can work with both categorical and numeric features. So that means it requires little data pre-processing. Okay. And it can also handle missing values in the data. So remember when you are fitting ML models, if your data has missing values, then decision tree based models can work, but other models like linear regression or logistic regression won't work. Okay. Then disadvantages. So prone to overfitting, especially when a tree is deep. Decision tree boundaries are axis aligned, which may not always provide the best separation between classes. Can be sensitive to small changes in data. So for example, if we change something like family to any other variable, then the model will be deemed inappropriate for use. Then may not perform as well as other algorithms. So ensemble methods. So ensemble methods are the advanced methods. So let's look at random forest, theory part, and C. So random forest is an ensemble learning method. So what do we mean by ensemble? So it means we are combining different decision trees and coming up with an improved prediction. So random forest is an ensemble learning method that constructs multiple decision trees and combines their prediction to improve the overall performance and reduce overfitting. So it works by training each tree on a random subset of the data by using a random subset of features for each split, resulting in a diverse set of trees that generalize better to new data. So just as I had shown you here, random forest takes in different decision tree models with different features arrangement and comes up with an average score. So that's how random forest works. So key concepts. So we have bagging, feature selection, out of bag, error estimation, hyperparameter tuning, advantages and disadvantages. So I'll take you through the advantages and the disadvantages, then the rest you can try read when you are free. So advantages and disadvantages of random forest. So advantages. So just like decision trees, they can handle both categorical and numerical features, robust to outliers and noisy data. So if your data has outliers, the model can perform well without any complications. So provides an estimate of feature importance. So you can actually use random forest to know which features are important in your data and which ones are not. Then it's less prone to overfitting compared to individual decision trees. Then error estimation provides a built-in for model evaluation without a need for a separate validation set. So for random forests, you are not really required to like create a test and training set. So it has an inbuilt way of testing if the model is performing well. Then disadvantages can be computationally expensive, especially with a large number of trees or features. Because remember, we are fitting multiple decision trees. So it means for a random forest, we can end up even fitting 100 decision trees for us to come up with one model score. Then may not perform as well as other algorithms. So for example, gradient boosting. So we will discuss gradient boosting in another class. Then less interpretable than individual decision trees. So you cannot really visualize how a random forest is because it's a combination of different decision trees. And if you even try to visualize them, it will be complicated for you to like understand how it works, because you won't know like the weight that each decision tree carries. Then predictions may be biased towards the majority class in imbalanced dataset. So for a dataset that has, let's say, 70-30% ratio split, so this model would come up with good predictions for the class that has the majority, which is 70, and for the other class it will have worse results. So yeah, that's the theory part for random forest and decision trees. So tomorrow we will go deep into it and work on the practical part. So the reason as to why I'm covering the theory part today for today is for us to have enough time to work on EDA and data pre-processing tomorrow without us having to look at the theory part. So that's all for today, guys. Thank you for joining. So if you have any questions, you can ask before we end our session there for today. So in the next 5 minutes, you can ask questions if you have any before I stop the class recording. Anyone with a question? Okay, so the silence suggests that no questions are there for today. So I'll stop the